I'm Brian, and I work at the marketing department at OWL Cyber Defense.
And hi, I'm Shawn. I'm our Government Solutions Product Manager here at OWL.
And we're here today to talk a little bit about our latest tactical cross-domain solution, Scowt and Scowt Compact. Shawn, can you tell me what the purpose of the Scowt platforms? Why were they built?
What we wanted to do is provide the same capabilities that we have for our customers from data center environments down at the edge, the tactical environment. So what we've done is really created small form factor, ruggedized platforms to be able to handle that kind of capabilities, but in adverse environments.
You mentioned hardware and force protection for mission information. What's that all about?
Well, here at OWL, especially in government solutions, we have a focus on Department of Defense, intelligence type communities, and market focus. And that market focus is really involved on collecting information, processing that information, and be able to provide intelligence products as a result of that information. What we've done is the ability, all that requires a lot of information transfers. And so what we've done is taken our data center capabilities, put in these small form factors, provide that absolute separation so that organizations know that they have no means, there's no means for exfiltration of sensitive data or infiltration into their infrastructures through our systems when they're trying to do these transfers with external entities like foreign partners, between classified domains or environments, or even open networks like the internet. These kind of solutions provide that separation between customers and the end or the source destinations they're dealing with.
What type of information is being protected through these one-way transfers?
Pretty much any type of information you can think of. What we do is we think of data in three basic contexts. One is highly structured data. That data in the DoD and IC environments are talked about fixed format messaging. It's well-defined, structured messages that can either be sent from the field operations or can be command control from the command post or intelligence headquarters. The other kind of data that we deal with is somewhat unstructured data or structured data. It could go either way. That can be video, voice, a variety of sensor data, can all be in that somewhat structured data type. And the last data type is really complex data. What we mean by complex data is very unstructured data, meaning that most anything could be embedded into that content. That could be actual executables embedded in the object. It could be steganography embedded in images. And lastly, it could be there's white space in documents that you can't see when you're looking at a document. An antagonist could actually put malcode into that white space. That's the different types of data that we deal with.
Well, how are these organizations using this type of information?
Well, as I just mentioned, in the fixed format messaging, that is used to get, for example, situational awareness information up to the command center. Command and control, as I mentioned, for battle space decisions can go from the command center back down to field operations. Sensor data can be used for force protection. So you have a command center looking at a video feed of a camp or a base, making sure there's no potential infiltrators into that environment. It can also be used by IT organizations where you have these filters going on firewalls, intrusion protection systems, IDSs, where content can get quarantined. You can pass that data up safely up to a forensics environment for further processing. And the last, as I mentioned previously, is Word documents, PowerPoint documents, things you normally think of in a normal office environment, but what they're used for is intelligence reporting. And the other notion of that is sometime in field operations, you find media with documents on it, and you want to get those documents up from that media up to processing environments. This safely gets that kind of data up to those processing environments. Those are just some use cases for what we're looking at.
Oh, that's great. So Shawn, how are these Scowt platforms used for all that?
As I previously discussed, we currently have data center-based solutions. 1U, 2U appliances or servers with our software on them. So we went through a lot of work how to get the capacity from data center appliances down into these small form factors. And one thing we did was looked at our smallest diode, which is about a 2x4 diode. We use that as the core of the Scowt Compact platform. And around that we have two processing environments, one for the source to handle data coming into the device, and a destination processing environment to handle data going out of the device. Now, the context of those processing environments can be different. We have one-way transfer systems that have all the same internal capabilities, but we have different software for that. And so that allows for organizations that need to quickly get raw data from a source to a destination. They can take that data through with little filtering, but still be able to meet latency, time for delivery requirements associated with that. But that same platform, we take a different software capabilities, which we call our cross-domain solution capabilities, and when we overlay that software onto this platform, or this one, then what we do is have all that filtering that I talked about, all that complex data, all the different structured formats. We have all that filtering capability, and that's how we're using these platforms. The same as in the data center, but now at the edge for the warfighter and the edge environment.
So how can these small ruggedized form factors process all that information?
What we've done is we've actually put in Xeon-based processors within these, so different forms, but still Xeon-based, which gets you a little bit better processing capability than other CPUs that we could put in there. Now with that comes heat, but you can see these are conductive cool platforms, and so they work in an environment so they can handle a lot of that heat before they worry about anything. Sometimes we have to have additional cold plates for them, but really that's an environmental consideration. But the big thing is with these is that with the Xeon processor, we actually, in the miniaturization of a lot of these components, we can have fiber and ether connectors on the endpoints here using mil standard connectors. So you can handle multiple kinds of interfaces within one connector. So that sort of helps us get smaller on these platforms. And specifically on the Scowt platform, what we've basically done is have an architecture now that can fit either into this type of platform, or it can actually be in a 1U chassis. So we do no changes to the internal architecture, but can apply it both in a data center model and at the tactical model, which gets more convergence and more benefits for our customers, meaning they don't have to change kinds of architectures.
Small ruggedized form factor seems to be key for the tactical solutions. Can you tell me a little bit more of the difference between the two devices?
Yeah, some of it is visible and some of it isn't. For example, just the physical size. And this is a little bit larger than a hand. It's 6 by 8, still about 1.6 inches high. Same kinds of general connectors for both systems. What we really provide is a data port for source, a data port for destination, a management interface, and an admin interface for things getting, like we talked about earlier, quarantine data and log data off these platforms. So that is the notion of this one. As you can see, this is about half the size of this, meaning from a length point of view. So this really can be put into a rack, or it can be two in a rack. For example, I talked about the one-way transfer customers. They might have one going low to high and have a separate one right there on the same shelf going high to low. So they are both designed to meet the mil standard 810H standards for ruggedization, and that's things like heat and moisture and shock and vibration, things of that nature. They're both DC powered. They both can be put into a frame, whether it's the bulkhead of a ship or the frame of an airplane or some kind of collection system of that nature, or even an MRAP vehicle for actually when you're down on the true edge out in the mountains. You can put these things into those environments. So what we want to do is have as much consistency between the two platforms, yet be a viable notion of environmental controls or constraints and be applied to both. Most importantly, the main reason we came up with these is the complete move by our CDS market to raise the bar mandate. And there are some very specific hardware requirements that are easily addressed in the data center, but are a lot more difficult to address within these smaller footprints. And so we did a lot of engineering to be able to meet the RTB mandated requirements for hardware.
It's interesting, Shawn. And thanks for all the information today. If you have any additional questions or would like a demo of one of these products, just contact us through our website or our chat bot.